Welcome to this class. Today in information technology, we will be continuing from where we stopped. In the previous class, we started looking at data and information. Where we talked about some system theory, different types of system theory. We talked about the business system. We talked about system environment. We talked about accounting information system, the accounting environment, and the things, the different categories and properties of each of these terms. So today, we will be looking at information technology as a whole. The title of this course is Information Technology. We had looked at what information is, the different types of information. We had also analyzed technology, what technology is, how is it utilized, how is it formed, and its usefulness. So in today's class, we are going to bring the two words together and find out what these two words, when brought together, form a particular word, and what does it stand for? What does it entail? What is information technology? So, in the definition of information systems, no reference was made to any form of mechanization. It is a definition of how information is used rather than how it is obtained. In information technology, processing is carried out with the assistance of machines, as electronic machines. So IT here, that is information technology. It has to do with processing, okay? Because information system has to do with how information is being obtained, how information is used, and not how it is obtained. That's for information system. It defines how information is used rather than how it is being obtained. But then in information technology, we look at the different processes, okay, carried out with the assistance of machines. Now, information technology is a computer-based information system where we make use of computers. Computers has to do with machines that assist human in carrying out a particular task. So IT is a computer-based information system in which the computer system plays a major role. All the various aspects of electronic technology includes A, the use of microcomputers for the processing and storage of information. So we make use of microcomputers to process information, that is from raw data to information, and then we also store this processed data, which is information. B is also the application of electronic spreadsheets to the modeling of business problems. The application of electronic spreadsheets to the modeling of business problems. The use of word processing software for preparing standard reports and other correspondence at high speed. For those of us who, of course, if you're conversant with the computer, we have what we call Microsoft Word. So we use the Word to prepare reports and other correspondence at high speed. So instead of writing the report, we make use of the word processing software. But then this makes information processing and information retention faster, easier, and more accurate. So the spreadsheet is used to model business problems. We have the spreadsheet, we have the Excel sheet that is being used to solve problems and for presentations as well. Then we also have the use of electronic mail, that is email, for transmitting messages. This partially eliminates the physical postal system. Now, yes, we're looking at the high point of the information technology, and we say that IT, that's information technology, is a computer-based information system. Okay, so it makes use of computers. And then the use of these computers now, because of the IT, we have what we call the email, electronic mail, that we use to transmit messages. So we no longer have to make use of the post office like we used to in just sending a particular letter from one place to another. But with information technology, we can actually do that in a split of seconds. IT also has brought about the introduction of economic trading, that is e-commerce, e-marketing, and electronic banking, which includes principally electronic money transfer. Yes, as a result of information technology, we can now do what we call e-commerce. That is, you sell things online without necessarily having a physical shop. So someone can stay in Lagos and another person in Abuja will be aware of what he or she is selling in Lagos, can see the product, place an order for it, and have those products delivered to him in Abuja. Now, this is made possible because of information technology, which is a computer-based information system. And through information technology, we also have what we call e-marketing. That is, marketing activities are being done online. So you don't really need to move, or we have 1 million people in a particular community, particular location. You cannot go around meeting those people one by one. It would take years, okay? But through information technology, you can market your product and service online and you reach this 1 million people in a short period of time. So nowadays we have what we call adverts. We have ads that are running on different social media platforms, and not just social media platforms, even on normal devices, other applications, you have ads running. So people have, there's a wider coverage and a lot of persons can see what you're doing and then patronize you for your goods or services. Information technology has also brought about electronic banking. Okay, we no longer have to go to the banking hall, pay your way down there to the banking hall, join a queue simply because you want to send money to somebody. So with e-banking, we can now do what we call electronic money transfer. So you could just stay and send money to somebody. Unlike in those days, many years ago, where we have to send someone that is going to a particular location, give the person money to give to your uncle in the village. But now you can send money to your uncle right where you are. And all of this has been made possible because of information technology. Information technology has brought about the introduction of electronic library, which enables the business to conduct its activities in a more efficient manner and stand above its competitors in the same trade. Now, unlike before, we usually have physical libraries where you would have one library in a particular location for everybody in that community. But then now we have what we call e-library, electronic library, where with our electronic gadgets like our phones, tablets, laptops, desktop computers, we can read. Okay, you download books online, you have them stored in your phone, and then you read them from time to time. So we don't have to go about looking for how to buy a particular book somewhere, send it down, but just in our smartphone, we can have more than 2,000 ebooks stored there. So information technology has brought about the introduction of electronic library. So this helps businesses to conduct their activities in a more efficient manner and helps them to stand above their competitors in the same trade. Another importance of information technology is that electronic funds transfer, that the means of transferring money from one bank account to another bank account electronically. Another is data transmission. Through information technology, we can now send data electronically from one place to another. So types of decisions. Yes, of course, accounting information system, information itself is prepared so as to enable stakeholders, management, and other concerned persons to be able to make useful and informed decisions. Okay, so what are those types of decisions that will be made via the information that has been processed? One major objective of the accounting information system is to provide information for management decision making. The ATSWA, that's Accounting Information System, to meet these objectives. To understand the roles played by IT and the design of such an AIS, we now explain the kinds of decisions made by an organization. Now, these decisions can be categorized either in terms of the degree of structure that exists or by the scope of the decision. So now, to understand the roles that have been played by IT and the design of AIS, we now have to explain the kinds of decisions that organization makes. And these decisions are made possible because of the contributions played by information technology and the design of the accounting information system. So the decision structures. Decisions vary in terms of the degree to which they are structured, among which are, first, highly structured decisions. Highly structured decisions are repetitive, routine, and understood well enough that they can be delegated to lower level employees. In fact, such decisions can be automated. Now, it has a structure. It has a laid down guidelines and procedures, okay? So much that it can be delegated to a lower employee. So you know that when a student comes into the school, the first thing is you register, find out what the person wants to do, register the student, take the students to the accounts department, and all of those. So it already has a structure, a laid down. So someone already knows what he or she is supposed to do. So there is less of your subjective opinion, but rather the objective one. So it already has a laid down procedure that anybody can actually handle that task. So for example, we have decision to grant credit to established customers can require a lot of criteria, which could be personal identification number, customer credit limit, and the current balance. So whoever is given this task knows that anybody who comes for a credit facility has to present the personal identification number, the customer credit limit, and the current balance. These are things that he has to request for and to check. So we also have semi-structured decisions. So here, these types of decisions are characterized by incomplete rules for making the decision. There is need for subjective assessment and judgments to supplement formal data analysis. Such decisions can be made using computer-based decision aids such as neural systems, decision support systems, executive support system. For example, setting a marketing budget for a new product. Now, here it is semi-structured. Now, it is not highly structured like the first one. Here, there are the rules, there are incomplete rules for making a decision. Of course, there are rules actually that you have to follow. But then allowance is being made for certain personal observances. For example, when making marketing strategy, we look at the marketing status of the other products, the level of advertisement, and other subjective decisions. So now, in marketing, for example, bringing up marketing strategies, the company cannot have a particular marketing route. Okay, so you can come up with your own creative initiative on how a particular product should be marketed. Okay, so it is structured because, of course, we have to look at advertising, the other product, what competitive advantage do we have over them. But then there is allowance, there's room for you to also make use of your subjective opinions. We have unstructured decisions. They are non-recurring and non-routine. Examples include choosing a cover for a magazine, hiring a senior management, and the choice of basic research projects to undertake. So here is not a routine thing, okay? We know that for a highly structured work, assignment, or task, for example, cake, you know that for if you're making a 5-tier cake, you have to make use of 5 kg of flour. Okay, it's already structured. You already know that that's what this has is supposed to be. And after that, you have to make use of 5 eggs, 3 kilos of sugar, and the rest is already structured. But for the unstructured one, it is not a reoccurring routine. Okay, it could be a once in a while stuff. And then because of that, we could decide how we want to do it, anyhow we want to do it at that particular point in time. For example, we have choosing a cover for a magazine. The cover of a magazine does not have to be the same every year and every time during the publication. So these are also unstructured decisions and the rest of them. So in this case, there is no framework or model. In this case, no framework or model exists to solve such problems. Instead, they require considerable judgment and intuition. Nevertheless, they can be supported by computer-based decision aids that facilitates gathering information from diverse sources. So these decisions, even though unstructured, are made based on information that has been gathered by the computer-based sources. So looking at types of decisions, we have decision scopes. So the scopes of decisions here, we have operational control, we have management control, we have strategic planning. So let's start with the first one, operational control. Operational control is concerned with the effective and efficient performance of specific tables. Lower level supervisors and employers face semi-structured or structured decisions involving operational control. For example, includes decisions relating to inventory and stocks management, and extending credit. So operational control, it means there's a control as to how the things are being carried out. Control, the operations and activities are being controlled significantly. Okay, so we have a supervisor who controls and monitors what the lower level employees are actually doing. You have management control. This is concerned with the effective and efficient use of resources for accomplishing organizational objectives. Middle managers deal with semi-structured decisions involving management control. For example, budgeting, developing human resource practices, deciding on research projects, and product improvement and management control activities. So unlike the operational control where you monitor the task that is carried out by the employee, the lower level employees report to the supervisor and all of that. In the management control, they are concerned with the effective and efficient use of resources. So they make policies that has to do with the overall control of the activities there. So they are involved in budgeting, they develop the HR practices, research projects, and all of those. So that is their scope of decision making. They're not bothered about the who is on shift today, who is supposed to submit this, but their scope has to do with the effectiveness and efficiency of the organization. Then we have strategic planning. This one is concerned with establishing organizational objectives and policies for accomplishing those objectives. Top management faces unstructured and semi-structured decisions involving strategic issues. So here, strategic planning has to do with you establish organizational policies for accomplishing those objectives that have been set by management. Okay, the objective is that we intend to increase to the goals and objectives include growth, sales growth. So how do we go about this goal? What are those things that we're supposed to do, either on a weekly basis, on a monthly basis? So top management faces unstructured and semi-structured decisions because they don't have a particular way of doing it. They also have to make their own research based. They also have to employ their wealth of knowledge and experience, and also all of these will be contributing factors to the decisions that they will make. So examples of strategic planning include setting financial and accounting policies, developing new product lines, and acquiring new businesses. So there's no particular structure, but however, it's semi-structured because they have to depend on information that has been researched using computer-based sources. So look at data presentation in a computer. How do we present data in a computer? The introduction of computer technology into information systems compels us to learn how data and information are transformed or coded to facilitate their storage and processing in the computer-based information system, CBIS. So here we go about coding in computer science. How are these data, how are they being sent into the system for them to come out as information? So there are two types of data, namely characters and numbers. A character is an alphabet or any special symbol, such as punctuation marks. So for example, character sets includes, we have 26 uppercase alphabets. Uppercase means the capital letters. So we have A, B, C down to Z. Then we also have the 26 lowercase alphabets, A, B, C, D to Z. And then we have the punctuation marks, the colon, the semicolon, the full stop, the comma, the apostrophe. And then we also have special symbols, asterisk, plus, minus, exclamation marks, and all of those. So a number is composed of digits, and there are 10 of such digits. Every number is composed of 10 digits, either from 0 to 9. Every other numbers has to do with bringing 2 or more digits together to form a new number. So we also have 10 digits in the decimal. We also have digits in the decimal number system. So example of decimal number system, we have 5.1, we have 126, we have 5897. So a data that is a string of alphabets and numbers is called alphanumeric. That's combination of alphabets and numbers. We now have a word called alphanumeric. So ABC 1, 2, 3, 4 is alphanumeric data. So external data representation. This is the representation of data in the usual normal language of the user. Usual normal language of the user. For example, the use of English alphabet to represent characters. When documents are presented for coding and processing, the data in the document is an external representation for the computer. So here, when I'm looking at the external aspect, which is, which is the normal language of the user. So you want to type in Okon is a boy. So externally, it is Okon is a boy. So this is what is which is what the user can actually understand. Then we have the internal data representation. Physical devices used to store and process data in computers are two-state devices. So we have what we call punch cards, we have magnetic devices, and we have conducting devices. Now, this one looks at the internal data representation. This one goes beyond what the user can understand or can code. This has to do with more of what goes on in the computer system. So the first one we have is punch cards. For the two states are the presence and absence of a hole on the card. You know how you could use a pin to punch something, to punch holes. So you have places that there are holes and where there is no hole on the card. For magnetic devices, the two states are achieved when a magnetic surface is magnetized in either one or two opposite directions. For conducting devices, the two states are achieved when the material is in conducting mode or non-conducting mode, as in semiconductors. So thus, all data to be stored and processed in computer are transformed or coded as strings of two symbols. One symbol to represent each state. For convenience, let us denote the two different states by 0 and 1. So in punch card phenomenon, 0 represents a punched hole and 1 represents the part that has not been punched. In magnetic devices, 0 represents magnetic aligned left to the right side, and 1 represents magnetic poles aligned to right to left. In conducting devices such as diodes, 0 represents conducting, 1 represents non-conducting mode. In general, for any switch, that is a device that can exist in two states, 0 represents off, while 1 represents on. So now, numbers are being used to represent the different aspects of these devices. Consider punching card, 0 represents where you have holes, while 1 represents where we have where the parts have not been punched. We also have for conducting devices where 0 represents conducting and 1 represents non-conducting. In magnetic devices too, 0 represents align left to right, while 1 represents right to left. So we also have what we call bits. Bits. Bits are two symbols, 0 and 1, which represent binary digits. That's base 2 numerals, binary, each of which is called a bit. Thus, a bit is the smallest unit of data in a computer system. Smallest unit of data in a computer system. The string of bits is then used to code a data in a computer. So the number of bits in each string will depend on the technology. The number of bits in each string depends on the technology, that is architecture of the computer involved. So for example, in a 2-bit computer, each character is represented by 2 bits. So the number of bits in each string, it depends entirely on the type of technology that is available in the computer system. So possible characters then are 00, 01, 10, or 11 because it is a 2-bit system. So you can't go beyond 2 in one string. So thus, the maximum number of characters that can be processed by a 2-bit computer is 4. That is 22. For a 3-bit computer, the maximum number of characters that can be processed will be 23. Okay, that's 8. And the possible representation of the characters is we can have 000, that's 3, or we have 001, or we have 010, or we have 100, or 101, or 110, or 111. But it cannot go beyond 3 characters. So for a 4-bit computer, the maximum number of characters that will be processed will be 24. Okay, 4, 24, that's 16, and the possible unique representations will be 000, that's 0 in 4 places, 3 zeros and 1, 0010, and all of these. So these are the possible representations because they are just 4. Okay, in the normal usage of data, there are 26 uppercase alphabet, that's capital letters. We have 26 lowercase letters, lowercase alphabet known as small letters. We have 10 decimal number digits, that's 1.0, 2.0, 3.5. We have 36 other special characters. So hence, in standard usage of data, we need a computer that can process at least 26 plus 26 plus 10 plus 36, 98 unique characters. That's 26 uppercase alphabet, 26 lowercase, 10 decimal number digits, that's 0 to 9, and 36 special characters. So we need a computer that can carry out 98 unique characters. So for such an n-bit computer, 2n is greater than 98, and 9 is equals to 7. So since 27 is equals to 128, and 26 will be equals to 64. Okay. So hence a computer in which each unique character is represented by a string of 7 bits is adequate to code the 98 characters in normal usage. So in order to facilitate the exchange of recorded data between computers, coding of characters has been standardized. The standard coding form in which each character is coded using 7 bits is known as ASCII. That is American Standard Code for Information Interchange. So we have another coding form, which is International Business Machines Corporation, developed by IBM, in which each character is coded using 8 bits. It's known as EBCDIC. That is Extended Binary Code Decimal Interchange Code. So in the case of BCD, that's Binary Code Decimal coding form, each character is coded using a string of 4 bits. 4 bits. So that means it could be 0000 or 1111, but it doesn't go above 4 bits. So a byte is a string of bits used to represent a character. Please take notes. A byte is a string of bits used to represent a character. So for the BCD, a byte is made up of 4 bits. For the ASCII, a byte is made up of 7 bits, while for the EBCDIC, a byte is made up of 8 bits. So please take note. This will come out as questions, objective questions. So D, definition of a byte. In normal practice, a byte is defined as consisting of 8 bits. That's 1 byte is equal to 8 bits. This is the standard definition of a byte. It is a representation of a character That could be an alphabet, digit, or special character. That is, a character is made up of 8 bits. So a word is defined as a combination of 2 bits. That is, one word is equals to 2 bits. In IT, information technology makes use of bytes, makes use of bits. So bytes is made up of bits. Okay, byte is made up of bits, and then the maximum of bits in a string is 4 bits. So for EBCDIC, a byte is made up of 8 bits. So evolution of computers. So computers have gone through various classifications. So we're looking at computers, how these computers evolved in their different generations. So we have 5 generations. We have first generation, vacuum tube; second generation computers. Well, the distinct feature was a transistor; third generation computers, IC; fourth generation microprocessor; fifth generation, this is the year is our current age and beyond. So let's look at the first generation, 1939 to 1954, vacuum tube. Now, the main features of the first generation computers are: number one, these computers used vacuum tube technology. That's why you see part of the heading is vacuum tube. That's the distinct feature of this particular generation of computers. They were very unreliable for data processing. And these are the defects. They supported machine language only. They were very costly. They generated a lot of heat, which requires huge air conditioners. Their input and output devices were so slow, and it was huge in size. Okay, so unlike now that we can carry our computers about, okay, we can carry from one place to another, from one location. The first generation of computers were very huge. It was very costly. Not everyone, it wasn't a common thing for a common man to be able to afford. It generated a lot of heat that required air conditioners. Okay, their input and output devices were slow, and it was only machine language that they could support. So the second generation computers, 1954 to 1959, 5 years. The distinct feature was it had a transistor. So the main features of second generation computers are: the computers used transistors. They were more reliable in comparison to first generation computers. Now, there was an improvement, an upgrade. They were smaller size as compared to first generation computers. They generated less heat as compared to first generation computers, and they consumed less electricity compared to the first generation computers. So all the defects of the first generation computers we actually worked on to improve. It was an improvement, and this led to the second generation computers. So all of those issues in the first generation computers was worked on, as the second generation computers were a bit better in those aspects. So the third generation computers, what we call the IC, the distinct features of third generation computers was integrated circuits. So this generation was 1959 to 1971, more than 10 years. So the main characteristics of third generation computers are as follows. A, they made use of integrated circuits instead of individual transistors. You know that in the first generation was vacuum tube, second generation transistors, third generation is integrated circuits. So instead of transistors that was used in the second generation, there was an upgrade. And then we now had what we call integrated circuits. So in this third generation, the computers were smaller. Remember, the first generation computers were so huge, but then there was an improvement and the size was reduced in second generation. But in third generation, the size was reduced the more. Okay, it was smaller than that of the second generation. It was cheaper. It was not as expensive as the second generation computer was less expensive than the first one. But then the third generation computer was meant to be less expensive than the second one. It was more efficient than the second generation computer. It was faster than the second generation computers. They used high-level programming languages, images of high-level programming languages. In the first generation computer, the vacuum tube computer could only support machine language, but in the third generation, made use of high-level programming languages. The storage manager was magnetic storage. Storage media was magnetic storage. In the first generation, 1971 to present, made use of the microprocessor. The first generation, the distinct feature was vacuum tube. Second generation, third generation, integrated circuits. Now the fourth generation is microprocessor. Second generation was transistor. So the main features of fourth generation computers are, first, they used VLSI technology. They were very cheap compared to the earlier generation computers. They were portable and reliable. They were more portable. The computers are personal, leading to the name personal computers, PC. That's your personal computers, your only belongs to you, yours. And the computers are they are used pipeline processing for data processing. They use pipeline processing for data processing. The 5.25-inch floppy disk was introduced at this stage. The 5.25 floppy disk was introduced at this stage. These computers are microprocessors with memory disk and LCD display screen. So that's our computers, our laptops. So we now have word processing, spreadsheets, office automation software was introduced at this stage. Internet was also introduced at this stage. The fifth generation computers, that's present and beyond, nanotechnology, mixes of nanotechnology. So these computers are no longer data-based, but control-based. Some other features include use of ULSI technology for data processing, development of true artificial intelligence, development of natural language processing, advancement in parallel processing, advancement in superconductor technology. So this generation of computers are more user-friendly and they interface with multimedia features. So types of computers. A computer system can be defined as a data processing machine that is under the control of stored programs, which automatically accepts and processes data and supplies or stores the result of that processing. So the key elements in the definition is that a computer is an infinite machine that, number one, it accepts data, processes data into information using the logic applied by the end user, and then it stores or supplies the information and makes information available to end users. So we have another classification of computers, apart from classification by generations. One way to classify computers is the way data is presented in the computers. So this classification is as follows. A, digital computers. Digital computers are those in which data and information are represented in digital form by a coded set of electrical pulses. Examples are programmable calculators, mainframe, mini computers, and microcomputers. So what we mean here is that data and information are presented in digital form by a coded set of electrical pulses. So it already knows that 2 plus 2, for example, in a calculator, when you press equals to, should give us 4. B, we have analog computers. These are computers in which data and information are presented in a more direct manner by a physical quantity that is proportional to it or to its defined function. Example includes thermometer, pressure gauge, and voltmeter. So hybrid computers consist of the combination of both digital and analog computers. Okay, so they are brought together in a single system. They combine the high speed of the analog computer with the flexibility of the digital computer. They are mostly found in scientific and technical applications. So comparison of digital and analog computers, let's compare both of them. Now, digital computers have the advantage of accurate output. It has high arithmetic speed, especially when it has to do with solving mathematical problems. 2 times 2, you already have it as 4. It makes programming and coding quite easy. But meanwhile, analog computers are very cheap, but the output may not be accurate. And most of the computers in use today, we have them as digital computers. Classification of digital computers. We have 2 classifications of digital computers. We have the first one, general purpose, and we have special purpose. So general purpose computers are those digital computers, are those computers which are completely programmable and can be used to perform a variety of numerical calculations and business problems. That's general. It can be used for anything. You can use it for multimedia, you can use it for photography, you can use it for graphic design, it can be used for spreadsheets, can be used for for accounting and the rest. Meanwhile, special purpose computers are designed for special types of application and they have their programs pre-written. So the first one, digital general purpose computers. The computers that are used in the homes, schools, offices, and for business application are digital general purpose computers. So these computers are generally classified according to their processing power, memory capacity, and the number of peripherals that can be simultaneously supported, such as the first one, supercomputer. We have mainframe computers, we have mini computers, we have microcomputers. These are general purpose computers. However, the rapidly changing technology has made this traditional classification very difficult. In fact, today, many super microcomputers are more powerful in terms of processing speed than the mini computers, so we can at best use the following features for the classification: processing power, memory capacity, heat evolution, environment in which the computer is used, cost, security measures put in place in the environment, installation procedure. So maintenance of inter period, The number of peripherals that can be simultaneously supported. We look at the word size, the bus size, the capabilities of the peripheral devices, the extent of usage. The word size is the number of bits of data that can be processed in 1 second. Now, 128 bits microprocessor chips are in use. So let's look at these brief descriptions of this computer, that's supercomputer, mini computer, microcomputers, and the rest. Supercomputers are generally the most powerful, uh, more powerful than the mainframe computers and even faster. They make use of parallel processing. They are more expensive than than the mainframe computer, and it can work at extraordinary fast speeds and are exceptionally accurate. These features makes them to be used for A, as a computer, generated movies and commercials, B, and B, whether for forecasting and structuring module. So these are what these supercomputers can be used for. The major disadvantage are that it requires highly trained staff for its operation, and its software is quite poor. So let's look at the mainframe computer. The mainframe computer is very expensive, and it is a large system. It is used mainly by large multinational companies. Unlike the one that we can move around with, it is very expensive. It is a large system used by large multinational companies. It is capable of handling multiple simultaneous functions, such as batch processing and interactive processing under the control of operating system. It supports a wide range of peripheral equipment, example, high-speed storage devices and communication line. It involves large quantity of heat. It is normally housed in air-conditioned rooms, surrounded by security measures and run by a team of professional operators. It can run for several uninterrupted hours and has a large primary memory in the order of 128 megabytes, with several disk units, each with a capacity of 361. So yeah, these are not for personal use, like an individual or a family. It is used by large multinational companies because it is very expensive and it is a very large system. Now the functions, it just goes way beyond what the average everyday man would need a system for. It is run by a team of professional operators, not just an operator. Okay, so it's really big and really wide. So mini computers, they are smaller in size than the mainframe. It has low cost compared to mainframe. It is easier to install, but still by a professional. It is used by medium-sized companies. Its use has no complex management structure. It can be used in networking, and it is used for engineering and scientific application. Its capabilities are lower than that of a mainframe, but higher than that of a microcomputer. So a medium-sized company, even though the mainframe, you have to make use of professional operators, but here it's easier to install, but then you still need a professional to be the one to install it for you. The cost is lower than that of the mainframe, smaller in size. It doesn't really have complex management structure. Can be used in networking and all of those. So we have the microcomputer. It's used as part of a network. It is very small in size, usually placed on a table, but now in smaller sizes in form of laptop, pocket phone. So our phones, our laptops are now categorized as microcomputers. It consists of a processor on a single silicon chip mounted on a circuit board together. It has a keyboard to enter data and instruction, has a screen also called monitor or video display unit to display information. It has interface for connecting peripherals, example, graph plotters, cassette units, disk drivers, light screens, mouse, and joystick. It has small word length size, 32 bits. It's the cheapest in the range of computers. Example of which is laptop. It operates under normal room condition, unlike the mainframe. It can be operated by unskilled users. It can be installed by unskilled users. It is used as standalone computers and MIDI computers. We have what we call special purpose digital computers. Now, these computers are designed to carry out dedicated operations only. They are meant to handle a very narrow category of data processing activities, example, video games, air traffic control, cells of petrol from the tank, robots for processing, control and industry, meteorological station for weather forecast. Now, these computers are designed for special purposes. They are not for the everyday word processing, Excel sheet, Corel Draw, watching of movies type of computers. They are designed to carry out special purposes. So the computer that is designed for air traffic control is not the one you use in typing your projects. The one that is designed for sales of petrol from the tank is not the one that you use for calculations of mathematical equations. So robots for processing, control, and industry, even the computer used for weather forecast. I know we all call them computers, but they are not the same type of computers. It's not the same as the microcomputer, the PC, the laptop, and the rest of them. So these computers are often installed in devices whose function are completely unrelated to computing. For example, microwave oven, television set, compact disc, digital camera, video set, petrol gauge. The program, that is instructions, in a special purpose computer are permanently installed in the computer. They're permanently installed in a computer. So the programs are already installed in the computer. For example, television set will not now come and function as a microwave oven. The program's instructions have already been permanently installed in the computer. You cannot erase it or change the programs. So types of microcomputers. Microcomputers are personal computers designed to be used by one person at a time. Classifications in their category include, unlike the mainframe that needs a team of professional operators, in the microcomputers, it's designed for just one operator. It can even be an unskilled person. So example of computers categorized as microcomputers, we have desktop computer. Now, these are the most common types of microcomputers, and they are designed to fit into the surface of a desk or workplace. They are designed to complete complex operations in addition to having each component, such as the mouse, keyboard, and separate wires from the main unit and simply attached by wires. Okay, so they're the most common. You can go to an office, you see a desktop computer on a desk, with the big head and all. We now have the ones that have the flat head, So they complete complex operations, but they have separate components. You have mouse, keyboard, CPU, screen, and all of that. They are separate from the main unit, but they are all attached together with wires. They are attached by wires. Mouse is attached, keyboard is attached, Monitor is attached, the screen is attached, everything is attached, the printer is attached externally. They're all external components, but they are attached together by wires to form the main unit. We have mini tower. Now this is a version of a desktop computer, but has a smaller main unit or tower. This not only means it takes up less space on a surface or desk, but is designed to stand upright in any surface, whereas a desktop computer tower is designed to lay flat with the screen facing up. So in a mini tower is designed to stand facing up on any surface. Meanwhile, a desktop computer tower is designed to lay flat with the screen often on top. We have what we call workstation. Also another example of microcomputers. They are expensive. That's the first feature. High-end personal computers that have powerful calculating and graphics capabilities. They are frequently used by engineers for product design and product testing. So they are PCs, but this one has variation. It's not the regular computer that everyone is using, but this one is frequently used by engineers for product design and testing. We have notebook computers. Notebook computers. This can be as small as a physical notebook, hence their name. They can be great for commuters as they are still powerful, but very easy to carry about in your bag. That's notebook computer. We have the laptop. Laptop is bigger than a notebook and heavier, but it's still portable. As their name suggests, they are built to fit on someone's lap to enable the user to type and use anywhere, simply by placing it on their lap. So this one, you can use it around everywhere. Just like the name entails, this is for you to use it, place on your lap. And imagine if we do not have laptops or microcomputers, we'll still be stuck with mainframe computers where it is so large and not everybody can actually operate them. But here, it's something that is easy for someone to carry about and is to carry out your work. We have palm top computers. These contain several built-in or interchangeable personal information management functions, such as a calendar to keep track of events, an address and phone file, a task of list of things to do. Palm computers do not have disk storage devices, but with non-standard keyboard, not arranged or sized like a typewriter. So it doesn't have it doesn't have a storage device, right? But it has non-standard keyboard, unlike the typewriter. To use it to keep track of events, address, phone file, and to-do list of all the things you wish to do. So we have what we call pen computers. Pen computers. These are specialized portable computers that use a pen-like device to enter data. They can be used to write information on a special unit screen and can be used as the pointing device to select compressing choice presented on a system. Pen systems have special software that allows the system to recognize handwritten input. So a type of small pen input system is called a personal digital assistant or personal communicator. Pen computers are designed for workers on the go and often have built-in communication capabilities that allows the PDA to use voice, fax, or data communicators. Okay. So we've come to the end of this particular topic. data and information. We had considered information systems, considered what information is, what data is. We've also looked at information technology, how important it is not just getting information, but retaining, processing and retaining information. Looked at information technology, information system, accounting information system. We also considered the various decisions that can be made using the information technology. We've looked at the different classifications of computers, definition of computers, classification by generation, classification by use, by size, and all of those. The first generation computers, the distinct feature was that they made use of vacuum tubes. Second generation was transistors. Third generation was integrated circuits. Fourth generation was integrated circuits. Fifth generation is the nanotechnology. And then we've also proceeded to talk about the different computers based on the classification of mainframe, supercomputers, microcomputers, macrocomputers. Also broke down microcomputers into the different categories. We have the laptop, we have the palm top, we have the pen computers, we have the notebook computer, and all of those. So information technology, you can see it's very necessary, because for accountants, it's not just in the addition and subtraction. In fact, manual accounting has been eroded from the system, because now what we now make use of is basically the digital accounting practices. Okay, we now make use of computers, no longer manual. Everything has been computerized, even in the accounting world. So that is why this course is very important and very vital for all students, because in the digital age, everything is being digitalized. So even the accounting procedures, audit procedures, preparation of bank states and of financial statements, audit, bookkeeping, stock taking, everything has now been computerized. So that's why this course is very important. So in our next class, we'll be looking at computer hardware. Computer hardware. What is computer hardware? The layman definition is a computer hardware is just part of computer that we can see and touch. That's monitor, keyboard, and the rest. So we will be looking at computer hardware. Then subsequently, we'll also look at computer softwares. And then we'll continue proceeding. So thank you very much for joining us today. See you in our next class. Thank you.